Exercise 5.2 question number 9. Prove that the function f given by fx equal to modulus of x minus 1 x belongs to R is not differentiable at x equal to 1. Now we know that modulus function is everywhere continuous. So this function fx is continuous at x equal to 1 also. But whether it is differentiable or not at x equal to 1, we will check that. And how we can do that? By finding the right hand differentiation and the left hand differentiation. So here let us check the question number 9, to check if fx equal to modulus of x minus 1 x belongs to R is differentiable at x equal to 1. So let us start with this one. We'll find the RSD. Here right hand differentiation RSD equal to limit x tends to 1 plus fx minus f1 over x minus 1. So this will give us equal to limit x tends to 1 plus, what is fx? Fx is modulus of x minus 1. So modulus of x minus 1 minus f1. F1 will be 1 minus 1, that is 0. So mod of 0 is 0. So minus 0 over x minus 1. And here since x is greater than 1, so mod of x minus 1 can be done as x minus 1. So this will be equal to limit x tends to 1 plus x minus 1 over x minus 1, and that is equal to 1. Now let us find the left hand differentiation. So here LSD, LSD equal to limit x tends to 1 negative fx minus f0 over x minus 1, actually 1, and this is also 1, because we have to find that 1. So limit x tends to 1 into fx minus f1 over x minus 1 equal to limit x tends to 1 negative, what is fx? Fx is mod of x minus 1 minus f1, that is 0, over x minus 1. And since x is less than 1, therefore mod of x minus 1 will be written as 1 minus x, or minus of x minus 1, equal to limit x tends to 1 negative. If I need to remove the mod, I can write it as minus of x minus 1 over x minus 1, and this will give us minus 1. So what we can see here is that the RSD and LSD are not, RSD is 1 and LSD is minus 1 here. Therefore RSD is not equal to LSD. The right hand difference is not equal to the left hand differentiation. Therefore fx is not differentiable. Fx is not differentiable at x equal to 1. This is very important question. This is very important question in the sense that sometimes the board exam they may ask you, give example of a function which is continuous but not differentiable. So you can give the example of this question number 9th one, because already you know that we have learned earlier that whenever you have absolute function or modulus function, it is always continuous. So fx mod of x minus 1 will be continuous everywhere, and therefore it will be continuous at x equal to 1 also. But we have seen that it is not differentiable at x equal to 1. Number 10th, prove that the greatest integer function defined by fx equal to greatest integer function x, where x is between 0 and 3, is not differentiable at x equal to 1 and x equal to 2. So this is a very simple question. We know that here fx equal to greatest integer function x such that x is between 0 and 3. Now what we know that the greatest integer function is not continuous at integral points. We know that greatest integer function is not continuous at integral points, therefore see, it is not the function, therefore fx is not continuous, fx is not continuous at, what are the integral points between 0 and 3? They are 1 and 2. So fx is not continuous at x equal to 1 and x equal to 2. Therefore fx equal to greatest integer function x is not differentiable, at x equal to 1 and x equal to 2. Why? Because every differential function is continuous, and since this function is not continuous, so it cannot be differentiable. Again, I am repeating that every differentiable function is continuous, but here since we have proved that we know that here the function f is not continuous, therefore it cannot be differentiable. So it's a simple one.